Okay guys, so in this video we're going to talk about Redux, so let's get into it. Basically what I wanted to touch on here is a bit of a realization I had the other day, which was pretty much that after React added in the context API, I started questioning whether or not I still needed Redux, and I experimented with a few things and I found that although I still think that Redux is probably a safe choice for a lot of larger projects, I think that we've gotten to this point where we may not actually need it anymore. So I wanted to just show you how we can migrate from Redux, or like an approach to not using Redux, and why we would want to not use Redux, and why we may not want to migrate, like why we would want to keep it. So let's just talk about this first and foremost. Like Redux, just to get the basics out, is the de facto standard for everybody almost everybody who does React development to get the Flux architecture. And the Flux architecture, you can read about that. It's a different topic, but this is, for most people who use React, Redux is like an almost given tool to use. Now, there is something that I think we should think about, and that is, do we actually need it? Because the thing that Redux actually does is now supported through the context API. That used to be the case. It used to be the case that React didn't have first-class support for the context API, and all it actually allows us to do is to pass through a set of properties from one component down to a child component without having to explicitly pass it through every component that is between the top component and the bottom component. And that's very efficient, or rather it's very convenient for us developers to be able to express that something is global or something is shared between multiple components. And that's something we absolutely need. And Redux has been doing this fairly well, and there's still quite a lot of tooling that is involved that I really like with Redux. There's a very nice browser plugin that helps you with Redux and like shows you all these nice things, right? So Redux is absolutely a great thing. I love it myself. I think it's great. But I'm also one of those people who will claim, and this is my personal philosophy, and the thing I'm claiming is basically that the goal of frontend when it comes to the web is to solve the problem that you have with the least amount of code possible. And I think that since the context API is already part of the React framework, if we could just leverage that instead of using Redux, that would be the most efficient thing, because then we can cut out a dependency, we can reduce the bundle size and all these things. And what's even nicer is that I don't think that that's necessarily going to happen, but if for any reason there would be some development on React side, because remember, Redux is just a third-party library that is catering to the ecosystem of React. But React is the actual thing. So if they have a standard in that framework, the closer we can tie ourselves to that standard, the likelier our application is to stay relevant for the longer, basically. Because it might be the case, I don't think, as I said, this is going to happen, but Redux could go in a new direction, it could be deprecated, some change could happen in React that makes Redux unfeasible or clinky or untangible. There's all kinds of things that could happen that would impact how well Redux actually works. But that is something we don't necessarily have a risk for when it comes to, there's not much of a risk when it comes to the actual context API. So basically what I wanted to show you is my little setup here to where I can do like just an example of how to do this. So I created this extremely simple little application here. Let's actually look at the application first because I'm running it right now. So this is my application. It's a to-do app. Whoa, everybody loves to-do apps. And I can add a to-do like this, yada yada yada, and then I can remove them like this, so I can remove all. That's the entire thing, just to kind of show you that this is something that requires some type of event dispatching of some sort, right? So I'm using Webpack. We'll just skim through these files very quickly because this is mostly boilerplate. And then I have a tsconfig because, hey, I'm using TypeScript because I like TypeScript. And TypeScript is pretty gosh darn great, especially when you're doing some work like of this nature. So let's start at the top here. So here's my app. This is my entire app right here. So I have a React component that is going to be included in here. which is where I just render out the actual application to the DOM, right? And then I have a provider component, and then I have a to-do list, and that's my entire application. So let's just look at the to-do list here. So the way that I usually structure this is that I encapsulate all the things that are necessary into a component inside of its own directory, so that everything is, I go for a centralized approach where I don't split things at the conceptual level, that something is a component or something is a reducer, something is an event. I group everything in association to the entity that they are connected to. So here is that, and here's my to-do list, which is this simple little component where I have this little interface that I include, and this is where TypeScript really shines, because now I can actually express with the type system what it is that I want. And basically the thing I want is to be able to grab the context, which is this global thing. This is the thing that is being provided by the context API, and you know that because, as you can see, there's like, I'm not actually inside of, let's look at that again. I'm actually not passing anything in here, right? The provider is responsible for providing the context. So here I'm getting the context, and then I'm grabbing the state on the context, and there's a to-do list, and there's some to-dos, and then I do a map, and then I map over all of these to-dos, right? And then I have a to-do input, and then I have a button that you can click on, which is basically the one remove all. And here I can call dispatch, which is on this context container or this context object. And then I can call provide remove all to-dos, which is just an action that dispatches and says, hey, remove all the to-dos, right? Here's my to-do input, also not super interesting here, but basically I create an internal state, and then I have an update function and an onSubmit, which, as you can see here, is doing some boilerplate prevent default and prevent default, so we're not actually submitting things. And then I do a dispatch here as well, because I have access to the context, because, as we saw, I'm wrapping this inside of the provider. Now, the reason why I'm getting access to this is because it's not the whole truth. In the context API, you have what we call a provider and a consumer. So we know that the provider is this thing here, right? But we also need to declare a component as a consumer. And the way that I do this is that I create a function, a higher order function, that is going to wrap my component in another component, a consumer, basically. Then that consumer is responsible for injecting all of these properties that is like the app context that is coming from the provider, right? We'll look at that in just a moment, but you can just bring that with me, that there's two parts to this. The top level is that you create a provider at the top, and then you create a function that wraps the component that you actually want to be provided with the context of the application. And then we have a to-do, which is this little thing here. Nothing fancy here, but here you can see that we're both expecting the context and the actual to-do, and the reason why we do that is because of this thing here. As we saw earlier, I'm actually here passing in the to-do itself, which is just a string. And then we have the same thing here, where we have an onClick where you can remove the to-do, and that's just going to dispatch an action called remove to-do, and then it's going to take the string of the to-do that we want to remove, right? Right, and then we have some events, these things here, which is just an enumeration of the different types of events that you can have. And then we have our actions, and here we have just my way of declaring actions. So usually what I do is that I create a function that is a higher order function, and all it does is that it basically takes in, well, it's not a higher order function in this scenario, but it's just a function that is responsible for creating a action, and it takes in type parameters here, like the key and the value, and then I just pass in the key like this, and this is no way for me to type the output, and then I can actually create an interface that I call iAction, that is generic for all my actions, and then I can just declare what types they are, and this way I can actually restrict what the reducer is going to get, which is pretty nifty. Because when I go to the reducer, I can now actually express that I have an action that's going to be of type I-to-do list action, and a state, which is the application state itself. And then I can type check it like this. And this is and this should feel very familiar if you've used Redux in the past. This is just a reducer, and a reducer is just a function that takes in an action and a state and performs an update on, or a mutation on that state, and then returns the updated state. That's all it does. So this is like my component code, and this is pretty, I think that most of this should feel very familiar, apart from, of course, the way that you wire all of the plumbing up between the provider and the consumer in the whole context flow. But everything like this part should feel very familiar. So now we're going to have a look at my store, which is where I've actually declared my own stuff. So I have this reducer function here, where basically all I do is in a very similar way to how you use compose and connect when you use something like Redux or React Redux, where we basically wire everything up. So all I do here is that this file is responsible for including all of the reducers. I'm actually just importing every reducer that I need in order to create this super reducer that runs all across the whole thing, right? And this reducer is the top level reducer. It takes in the action, and it's going to be an action of any and an app state, because at this level I don't want the type system, because basically here I need to, because this way I can just keep as many reducers underneath as I want that takes in any type. All I really care about is that it is an action. I don't care what type it is, because that way I can keep this as generic. It's just important to me that the underlying code has a type system, because this is something that will change only when I add a reducer, but everything underneath will change quite often, where you change keys and actions and all of this stuff, right? And this is basically just glue code. And this is one of the things that I mean, this is my own implementation of this, but this is something that Redux has that is much nicer, and that is that they have there's a very nice browser plugin that allows you to see the events that are being dispatched. So when I'm working with this, basically I include this code. I put this usually under like a debug flag or something. But basically here you can see that this is just a hacky way for me to do this instead of using the Redux, this Redux plugin that I use for my browser. And this pretty much produces the same sort of thing, where I can see the dispatch and I can see the values and all of this stuff. So it's just it's a very primitive way to recreate the same thing, right? And then we have our list of reducers here in my reducer, and then I just called reduce. Easy peasy, with the accumulator, which is just going to be the state, and the H reducer, and then the H reducer is just responsible for taking the action and the state, and then I just run all of them, and then I get a result and I return that result. That's the entire reducer, because remember we have this global state that now is being just iterated over and mutated until it has a finishing state, and then we return that finishing state. So let's talk about state. So I have this very simple little state, which is I have this interface where I have, in a very similar way to what you do in Redux, I create a module level thing. Like I have my to-do list component or my to-do list state, and inside I just have a bunch of to-dos. And this is my init state, where I just create some default state. And as we saw here, when I refresh my application, this is the first thing you actually see. And this is the thing that you're doing. So this is very extensible. It works the same way in Redux. You just create new models or rather new sections of the state, so you can just keep a separation of concerns between the different component states. Here is my actions, or the helpers for there, where I just have this interface where I have an interface of iAction that has a K and a T. So the type is K and the value is T. And then we have create action that takes in these generic properties. And well, look at that, it was actually higher in the order function. Yeah, anywho. And then you take in the type, and it's going to return a function that expects the value of T. And then it's going to return an action of K or T. And this is the way that just a very generic way for me to because it's boilerplate writing this over and over and over. So having a function that just spits out the same action structure to the object is very nice. But I think that it's even nicer when you create a type system, because then you can actually assert that, hey, the function or the action function that I created is going to expect the correct value. So you can't just pass something weird in there that shouldn't be there. And then we have my context. And this is just the interfaces, like the init context and the interface that expresses what it is that I want. So remember we had our app state. And apart from the app state, which is holding all of the state of my application, I have the dispatch function. And the dispatch function is the same thing, it's conceptually the same thing as you have in Redux. It's just going to take a sequence of actions, so like this, varying a length of actions. So if you want to dispatch many actions, like one after each other, you do it this way instead, to avoid race conditions or anything like that, which is something that I discovered later because I made a mistake where I just passed literally each, and like I called dispatch several times when I had a sequence of actions. And that's something that Redux takes care of, where there was no race condition in their situation. I could probably fix it in a nicer way, but this works very well as well. And is actually a little bit nicer, I think, as well. Anywho, then we have the init context, which is just the initial state of our context, and then dispatch is just going to be an empty function, and then we're going to include the init state, right? And now, finally, we arrive at the store. This is where all the magic is happening. Make sure that you're in a room alone now, because this is super secret code. So, context we create through create context with the init context, as we saw earlier. And then we have our provider state, which is just going to be the app state itself. And then we have our provider, and it's just going to have the dispatch function and a state, which is just going to be, hey, the init state, right? And then we have our dispatch function, which is going to take our actions, and then it's going to go through each of the actions, and it's going to call reduce. And here we have our state and the action that we're actually going through, right? And then we basically just loop over. And we call the reducer. Remember the top level reducer, which inside of it has all the reducers of the application, and then it just calls them over and over and over and returns the new state. And then we use the internal set state, and we just set the app state like this. So basically anytime we do a dispatch, we just set the new application state and then we render. And this is, this is one of the limitations, because this is of course going to be less performant just out of the box than what Redux actually is. But as I said, it comes down to, do you want to have, do you actually need to have that optimization? If you need that optimization, then use Redux. If you don't need it, then this is a way for you to actually reduce the amount of code that you need in your application. And I'm in favor of this because I think that using pure components in order to stop re-rendering things unnecessarily or something like that is a better long-term plan than just depending on Redux. That's just my opinion anyway. And then here we see that we use context.provider in the exact same way we do, well, this is the standard basically. So this is the standard interface. You declare a context as we did up here, and then you create the provider, and it's going to take a value, and it's going to just pass in basically the state or the context, which is just going to be dispatch with the dispatch function, and the state, which is going to be the application state. And then it's going to pass that through to its underlying children. And here I've created a bit of typing, which is where we create just a higher order function that we call with app context, as we were saying earlier, instead of, because the thing is, this is just a convenience for me so that I don't have to write this boilerplate code in every single situation, but I could do this instead if I wanted to. I could just grab the context and call consumer, but I thought this is, although this is a little bit more advanced maybe than it has to be, it's less approachable for a beginner. It's something that in my opinion, it's code that it's glue code that will never change, and I think that it provides enough value to warrant the extra complexity. And basically all it does is that I've created a type that is called emit, and that takes a t and a k, and that's going to extend a key of t, and then we're going to pick something like basically one of the properties from t, and we're going to create an exclude where we basically exclude one of the keys that is from t, which is going to be a type of k. And basically what that means is that it allows me to do this. So I can now express that with app context is going to take a p, like some type of something that extends context, like a type of context. And then t is going to be an omitted version of p where I remove the context key. Because remember, it has to be a key of the thing that I'm passing in. Because the reason why I do this is because if I don't do this, then my interfaces will require me at every turn, like I'm saying here that I have declared that this thing should take a context, But if I remove that omit, then I literally have to pass the context in. Because remember, the TypeScript type checker will actually not figure out that, all right, I don't really have a context. It's like magically being injected through my properties, because my interface here is declaring that my component takes a context, but I don't want that. I don't want to have to say on my component like this that, oh, the context is being passed in. That's why I want to omit the context property from the interface that is being expected, basically. And that's pretty much what's happening there. And then everything else is pretty much the same as you would expect. So it returns a function. This is the higher order function that takes in the properties, which is going to just be properties of t. And then we wrap that whole thing in the context consumer, and then we're going to get the app context in. And then I use a tsignore here basically because it conflicts with the way that I'm doing this. A little bit of a tricky thing to explain, but just trust me on this one. And then we basically say that, all right, component, which is the thing that we're actually passing in here, and it just has to be like a component class of some sort, which takes these properties that we were talking about, basically just any property that you want to pass into your component. Then we spread those components over the component, and then we pass like literally in the context with the value that we are being provided, which is going to be the app context. So I know this was a little bit more advanced, and it's not super beginner friendly, but I sort of swear by this. I've had great success with this, and it works really, really well. I use it for pretty much every of my own projects and a few of the professional ones that I've been building as well. It works very nicely, I think, and it does exactly what I want without the need to depend on Redux unnecessarily. So this is basically me just showing you, well, there's a bit of CSS here and some HTML and stuff. We don't really have to talk about that, I hope. So let's get back to the summary. So I just showed you a way to move from Redux to just using the standard React API. I personally have made this choice that, like, until I find some really compelling reason to stick with Redux, I think it's nice to be able to cut a few more dependencies out of my stack and just focus and just use the thing that I actually really need and depend on, which is React itself. But if I still find a situation where, all right, this is not going to work all that well, we need some type of performance, or if I have a project where I already use Redux, then I will just keep on using Redux. But I think it's nice to have the alternative to not use Redux when I can avoid it without pretty much any cost. I mean, setting this up takes a few extra minutes, and when you have set it up, you're pretty much guaranteed that this will be future-proof. But as I said, if you're concerned about performance or stuff like that, using Redux is probably the way to go. So I hope you found this interesting. Have a great day.